Welcome to Peace Online Basic Chemistry. If you are new on our page, please subscribe, like, and share our videos. Friends, today I'm welcoming you to the exciting world of acids, bases, and salts. Please come along with me. The first question we'll be answering is, what are acids? By definition, acids are substances which produce hydrogen ion or hydrozonium ion or protons in water as the only positive ion in solution. Now, let's talk about the properties of acids. One of the easily identifiable property of acids is that it tastes sour, like in unripe fruits. Another yet easy property to identify is that it turns blue litmus red. This can be easily seen in the lab. And acids will react with metals to give metallic salt and evolve hydrogen gas. Right on the screen, we see magnesium reacting with sulfuric acid and chloric acid to give you magnesium salt and hydrogen gas. Some very common examples of acids are chloric acid, sulfuric acid, nitric acid, carbonic acid, phosphoric acid. We also have organic acids. Now, let's answer the question, what are bases? Basically, bases are substances which dissolve in water to give off hydroxide ions. They are usually negative ions. Just like for acids, let us learn about the properties of bases. For bases, the first identifiable property is that it has a bitter taste. Bases are known to turn red litmus paper blue. This can be achieved simply in the lab, and also can be easily identified as it has a soapy or slippery feel when touched with the hands. An example or examples of common bases are sodium hydroxide, potassium hydroxide, lithium hydroxide, barium hydroxide, ammonia. From the aforementioned properties, we can easily deduce the basic differences between acids and bases, from the ions they produce while dissolved in water, to their reaction with different litmus colors, to their taste, to the feel in the hand and their basic reactions. Now let's see what happens when acids react with bases. This is usually called a neutralization reaction. Acid reacts with base to produce neutral salts and water only. A popular example of this is the reaction of aqueous solution of chloric acid and aqueous solution of sodium hydroxide. This produces your table salt and water. The pH scale measures the level of acidity of a substance. It's between 0 to 14, where 7, the center, is the neutral point. Less than 7 is acidic and above is basic. Another topic we want to look at is acidic strength and basic strength. The level of ionization of acids in water determines its strength. When it is strong, it completely ionizes and partially ionizes when it is weak. Sulfuric and chloric acid are examples of strong acid, while phosphoric and acetic acid are examples of weak acids. Similarly, for bases, when there is a complete ionization in water, they are said to be strong. Examples are potassium hydroxide and sodium hydroxide. And also, when there is a partial ionization in water, they are said to be weak. Examples are ammonium hydroxide and magnesium hydroxide. Now, let us look at some common applications of acids, bases, and salts. Acids have been found to be very useful in our daily activities. Vinegar, which is acetic acid, has been found to be very useful, as well as tartaric acid, which is used in packaging of soft drinks and wines. They have been found quite useful in the manufacturing of drugs and fertilizers. The hydrochloric acid in our stomachs aids digestion. You can as well find acids in your batteries, your car batteries, your paints used in painting of the house, as well as its usefulness in the lab. Bases are used in the production of soaps and detergents. The milk of magnesia, which is magnesium hydroxide, is used in calming of the stomach acidity. They are also used in the production of baking soda, your toothpaste, as well as cement. They are also used in the production of fertilizers, as well as they are useful in the lab for lab activities. The use of salt stretches from our home front to the industrial. It is used in cooking, is used in flavoring our meal, in food preservation, purification of water, tie and dye, soap making, and laboratory use. We have come to the end of this class. Please subscribe, like, share, and comment on what you have learned. Thank you for watching and listening. Stay tuned for more.